Hello students, welcome to the lecture of structure of atom. Till now we have discussed about the Heisenberg's uncertainty principle and de-Broglie's hypothesis of wave particle duality of matter. From this, today we will discuss about the limitations of Bohr's model and why the Bohr's model failed. So, according to de-Broglie's hypothesis and Heisenberg's uncertainty principle, we had received some formulas. So, de-Broglie's hypothesis stated that matter like light also possess both wave nature and particle nature. So, since light or electromagnetic radiation have both properties like wave and particle, so any matter also has both these properties, and the wave nature or the wave form of matter is known as matter waves. Okay. So, from de-Broglie's hypothesis, we received this equation, lambda equal to h by mv or lambda equal to h by p, where lambda is the wavelength of the matter waves, h is the Planck's constant, and p is the momentum of the particle. So, here we can see that wavelength lambda is the wave characteristic and momentum is the particle characteristic. So, this was the relation of de-Broglie's hypothesis. So, let us look at some numericals based on de-Broglie's hypothesis. So, the first question is, calculate the wavelength of an electron moving with a velocity of 2.05 into 10 to the power 7 meter per second. Okay. So, we have to find out the wavelength and we are given with the velocity, and it is given for an electron. So, from de-Broglie's hypothesis we know that wavelength is equal to h by p and p is equal to mv. So, we know v and we know m. What is m? Mass of electron, which is equal to 9.1 into 10 to the power minus 31 kg. This is the mass of electron and v is given 2.05 into 10 to the power 7 meter per second, and we know the value of Planck's constant. So, let us put all the values Planck's constant is 6.626 into 10 to the power minus 34 joule second divided by 9.1 into 10 to the power minus 31 kg into 2.05 into 10 to the power 7 meter per second. So from this formula we get the value of P as this part is P. We get the value of P as 18.65 into 10 to the power minus 24 kg meter per second. So this is the value of momentum. So if we put this value in the equation of wavelength, we get 3.55 into 10 to the power minus 11 meters. This is the wavelength of the electron. So let's see another question which says mass of an electron is 9.1 into 10 to the power minus 31 kg if its kinetic energy is 3.0 into 10 to the power minus 25 joule, then calculate its wavelength. Now what do we know? That kinetic energy is equal to half of mv square. From there we have earlier derived this equation, that kinetic energy is equal to p square by 2m. Now p is the momentum and m is mass, and for finding out wavelength we need h by p. So we need to find out momentum from the equation of kinetic energy. So if kinetic energy is equal to p square by 2m, then p square will be equal to 2 into ke into m, right? So p square is equal to 2 into kinetic energy into mass of electron. So this we get 54.6 into 10 to the power minus 56. Now what will be the unit? Joule is equal to kg meter square per second square into kg. So we get kg square meter square and second to the power minus 2. So momentum will be square root of this. So we get the value of momentum as 7.39 into 10 to the power minus 28 kg meter per second. Okay, so wavelength will be equal to h by p. So if we put the value of p in this equation, we get so the value of wavelength comes as 8.97 into 10 to the power minus 7 meters. So this can be written as 897 into 10 to the power minus 9 meters, right? And 10 to the power minus 9 meters is nanometer. So we can write 897 nanometer. Okay. Now this was the de-Broglie hypothesis. The second thing we had learnt is Heisenberg's uncertainty principle. What was the main statement of Heisenberg's uncertainty principle? Heisenberg's uncertainty principle said that we cannot measure the exact position and exact momentum of a moving electron simultaneously. That is, if we try to find out the exact position of the electron, then we will be not able to find out the exact momentum, and if we can calculate the exact momentum, then exact position cannot be determined. So according to this, he considered that if the uncertainty in position is considered as delta x and the uncertainty is in momentum is expressed as delta p, then we get this statement: delta x into delta p is greater than equal to h by 4 pi. This was the main statement of Heisenberg's uncertainty principle. In the last lecture, from this statement we had derived many other similar statements. So let's solve one question from Heisenberg's uncertainty principle, which says if the electron is located within 5.5 into 10 to the power minus 5 angstrom, then what will be the uncertainty in velocity, and can the electron reside within the nucleus? Under these conditions. Okay. So what is said that the electron is located within this, means this is talking about a range. This is not the exact position, rather it is expressed in the form of a range. So this is the uncertainty in position delta x. Delta x is 5 into 10 to the power minus 5 angstrom. Means the electron can reside in any position within this region. So this is the uncertainty of position. Now we need velocity, uncertainty in velocity, right? So from this equation we can write delta P as m delta V into delta x, which is greater than equal to h by 4 pi, where m is the mass, right? Since the mass is not uncertain, we know the mass of electron, so the uncertainty is only in velocity. So we need to find out delta V. So we can write delta V as h by 4 pi delta x m, right? Here we know the value of Planck's constant, we know the mass of electron, and we know the uncertainty in position. So uncertainty in velocity will be okay. First of all, we need to do one thing before starting the calculation, that is, the position here is given in angstrom. We cannot calculate this in angstrom because the other values, that is the value of h and the mass of electron, are in SI unit, right? The unit of h is joule second and we know the mass in kg. So we need to convert this value into SI unit, that is meter. So 1 angstrom is equal to 10 to the power minus 10 meter, right? So this will come as 5 into 10 to the power minus 5 into 10 to the power minus 10 meters. So this is 5 into 10 to the power minus 15 meter, right? So we can write like this. Okay. So delta V will come as 1.16 into 10 to the power 10 meter per second. This will be the uncertainty in velocity. Now the second part of the question was, can the electron reside within the nucleus under these conditions? So what happens? Uncertainty in velocity is this, and we know that the velocity of light is 3 into 10 to the power 8 meter per second, and here it is 10 to the power 10. So the uncertainty in velocity is greater than the velocity of light, which is not possible. So this condition is totally hypothetical. Therefore, electron cannot reside in the nucleus. Okay. Now, from the Heisenberg's uncertainty principle and de-Broglie's hypothesis, we get the reasons for the failure of the Bohr's model. So the first thing was, Niels Bohr didn't account for the wave nature of electrons. He didn't say that when the electron is moving in an orbit, it will have a wave nature. It will give rise to a wavelength. That was not accounted. And also, Heisenberg's uncertainty principle proves that we cannot measure the exact position and exact momentum of an electron. But Bohr said that the electrons revolve around the nucleus in circular orbits. We can specify its orbit as circular only when we know the definite path. But a definite path is known when we know the exact position and momentum or the forces acting on the particle at every point on that path. But that is not possible according to the uncertainty principle, because if we can determine the position, then we will not get the momentum. So we cannot not understand what forces are exactly acting on the electron at that specific point. Therefore, determining a definite path is not possible. That was the reason for the failure of Bohr's model. In the next part, we will discuss about the limitations of Bohr's model and we will introduce quantum mechanical model of atom. Thank you.